We're being live. Okay.
Oh yeah, you see it?
Mm-hmm. Something pops up on my screen.
Okay, great. Thank you so much for joining. Welcome to All Things Abacus. My name is Miss Lynette. I hope we're doing well. Okay, I think.
Yep.
Okay, good. Okay, so I wonder. I'm trying to do a different way of streaming.
Okay.
No, that didn't work. That didn't work. Okay, so. Okay, so I got that. Start streaming. Let's see if that works. Oh, do you see? Oh no. Hold on. On post on profile, posting groups. Do you see? Are you on YouTube? Are you on Facebook?
I want to show you.
I can get there. All right, I'm on Facebook.
I don't see it. Connect. Complete. Oh, hold on. Complete. All things. Abacus. Welcome. Okay, so add to my post. Go live. What do I connect? Oh, nuts. Where is it?
Nothing yet.
No. Okay. Let's see if I can change this. Settings.
They're so cute.
Stream. Live.
One thing though. This is the parts in the Minecraft epic bases and
No, I can't do it.
Gel build tips.
Okay.
Exit
Let's try.
Tombs, lofty wrap, sunken estate.
Alright.
Let me just show you. This is the
okay, you know what? I'm gonna try to figure this out later.
And
all right,
okay.
That's enough. Okay, sorry. I was doing it live and it's not gonna help. All right, so how are we doing? Okay, Alyssa had a couple of questions. Thank you, Alyssa. So you were asking for adding up the missing add-ins.
This big base on the
Yeah,
ground,
I actually was able to
if you this is
do a little bit of technology there.
What do you mean?
I'm so proud of myself.
Yeah, what do you mean by you did a little bit technology?
Well, I was able to upload.
Oh yeah, the pictures. Yes.
You might
Yeah.
like this.
Well done. Well done.
Yeah.
So shall we talk about the let's see. Does this work? Okay, yeah. So there was
like
the add-in, which was 65 equal plus 65 plus something equals 70. So what's the issue? The issue would just be that he would have to figure out that he has to subtract.
Yeah, you can do that. One of the things that let's see, what I did on there is, first of all, you notice, I wish I had my notes of what I sent you, but
yeah, you're gonna take a picture of it and we could see it.
Oh my goodness. Oh.
How about you be a clown, Max? You'll be a
'Cause
clown soon.
for one thing, you've got to get that X by itself.
Yeah, so that's what it would be, right? So what we're doing is we're trying to
Yeah.
understand that we're going to subtract, because if you have 65 here, you're going to minus 65 here, and you're going to minus 65 here. So on the abacus, it'd still be the same. We have 70 on the abacus, right? Like that. And then we take away 6 and we take away 5. We know that minus 5 is equal to minus the 10 plus the 5. So minus the 10 plus the 5. So
I'm gonna go get my book.
okay.
So on there, they mentioned about. I mentioned about there were 2 steps. So you could do, or one of the first steps that she used was basically, what's your partner's for 10? And so there was 65 plus what is 70, and then it went 65 plus what is like 90 or something like that. And so what we did is that
Oh,
that
right.
your partner, because there's 5 there, and the partner is
65. Yeah.
your partner is 5.
Yeah.
Let me go get the book so I can explain it. Hold on.
Oh, and then it was like 65 is equal to 90. And then okay, so what are they trying to do here? Oh, I see. I didn't see the pattern.
Where's my book?
To me, it just looks like they're increasing by 10.
Yeah, but I don't know why we need to do this.
I don't either.
I gotta find my.
I feel like it's more strategies that they're trying to introduce.
There, I found it.
Oh, good.
So, Abram already did the assignment. I was just, let me tell you what she says in here on that one. Okay, it was, what lesson was it? It was lesson activities. Is it 3 point? Okay, it's 3.2. So let me go there.
Okay.
So because yes, we can solve for x, but what I was doing, where's 3.2? Come on. That's 2.8. 2. Oh, come on. That's 3 point. Okay. So what her thinking of is, her steps are, first of all, she says okay, like let's say you're doing 38 plus what equals 70.
Okay. So 38 plus what is equal to 70. Okay.
Right. So the first step that she does is how many more ones do I need to complete a group of 10? And so in there, I said that, well, that is the same as basically making a 10. So you put 38 on your abacus, and you're going to go and make a 10. You're going to go 38 plus 2, because you know that 2 is 8's partner.
Mm-hmm.
So you go 38 plus 2. So then you have 40. And then her second part is, how many more 10s do you need to reach 70? Because you already know there's 70 there.
Okay.
And so then you're basically saying 40 plus 30. So you're putting the 2 for the ones place, and then you're basically putting 3 for the tens place. And that would be 38 plus 32. But what we're visually seeing is that, okay, we're making a 10 by going to the nearest 10 by plus 2, because you have 38 plus 2. And then after that, then you're doing the tens. So I'm throwing things out there, but I guess I was trying to take some of her steps and converting it to, well, okay, how would you do this on the abacus? Because let's say right now, what if Abram doesn't know that you're supposed to subtract on the other side and you're solving for x? So it's easier to know that, well, we know that 4 plus 3 is 7. So we know 40, the number between 40 and 70 is going to be 30. You've already put your 2 down because that's your partner to 10, you know. And it showed a visual picture of the rods out there, and it showed,
Right.
and so that's what I was doing, because the whole entire list, they have 65 plus what equals 70, 65 plus what is 80, 65 plus what is 90, and you start to notice at the pattern that it's going to be 2 in the ones place, the whole entire, it's going to be 5 in the ones place all the way down. And then you're basically doing the tens part. It's just looking at patterns, but you're using the abacus to do it. So upper way, you would probably do, you would subtract 65 and you would get 35 for if you were going to do 65 plus 90. No, actually 35 would not be it. That would be 25. Sorry.
So like, yeah, 90. Okay.
Do you know what I'm saying? So I'm throwing a wrench in there again about basically, you're finding let's make a 10, and then you're going and then you're adding the tens.
Right.
So that's what I was wondering how you would do that. And when I put the information in there, I realized that I might have answered my own question, but so I don't know if you got that what I was saying in the communities part when we were throwing a question out there.
Yeah.
So, but if you didn't get that, that's totally fine too. We can also go and do the multiplication questions that you had listed. So
there's a few thoughts that I have.
Okay.
Because I was trying to figure out like what's the goal and what's the point.
Mm-hmm.
So one of the things is we also have to pay attention to is in mainstream, they focus on the top number and not the middle, not the actual add-in.
Mm-hmm.
Right.
We know the actual add-in in there is going to be 5 because you circle a 5 and you know that automatically that the partners to 10 is 5 plus 5.
Right.
Mm-hmm.
But this is the difference between how mainstream thinks and how Abacus thinks. So for us, we don't worry about what's in the middle here because that never really changes.
Yeah, but you don't know what the middle is. And so so you would do the opposite. You would subtract, and that would probably be the easiest way of doing that. So I was just taking her 2 steps and converting it to
right. But that's the same thing as saying like, because what it is, it sounds like it's the precursor of doing 24 minus 9. And what they have to do is they have to take this a 1. They have to take this, and then you have to know that 14 is the same as 9 and 5, right? So this part here is where mainstream says, okay, you have to memorize 9 and 5 is a fact family.
I think probably in that problem, I think she's doing pairs of, what equals up to 100.
Yeah,
Pretty much that's what she's ultimately doing.
right. But that's
Um,
what I'm saying. It's like extra strategies of trying to get to the same thing that might confuse what's going on. Because in Abacus, we don't need to memorize the fact family of 9. We just need to know that minus the 9 is equal to minus the 10 plus the 1.
mhm.
So when we're looking at it, it depends on what the goal is. Is the goal trying to figure out, like, I guess the biggest thing is to, like, I guess the biggest thing is, what's the goal? Is the goal trying to pedagogy, think about, like, how are we going to solve for this problem right here? Or is it trying to find number patterns?
I
You know
think
what I
it's a
mean?
mixture of both because you already know there's already she's using 65 all the way down, and she's doing 80, 90, 100, and 110. So you automatically know, because it's the halfway between 65 and 70 is 5. So you automatically know that in the ones place it's going to be 5. That's your other partner to 10. So if you went 65 plus 5, so 65 plus 5 is plus the 10 minus
Right.
the 5.
But then that gets you to 70, and then you
That's
add another
70.
10.
And then you know that, okay, and then you see visually on the abacus, because you see 80 is right there. Oh, okay, it's just one more.
Yeah. Okay.
So that's that, and you visually see it. You visually see what you're doing on the abacus.
Yeah.
So what I wrote in my book with that problem. Let's see, where is it? Keep on getting. Where did I put it? Nope, it's page. Hold on. What I put on there? No, I put it in the mat. Hold on. I said basically, what is 8's partner when you're looking
Yes.
at 38? Or I
Right.
said, what are the friends of 10? Is what I put on there. And
Yes.
so then after that, we just do the regular, you just, then you put its partner there. 5's partner to 10 is 5 in the ones, and then you add it, and you get 70 and 80, and then you visually see, okay, 70 and 80, it's just one more 10.
Right. Okay. Good.
So that's mainly what I was doing. And then you notice the pattern would be 2 more 10s for 65 plus 90. And then 65 plus 110, that would be 4 10s, 45. So that, and then you just see the pattern. Abram had done a problem. The problem that he had done, I don't know if it wasn't adding up, but he saw the pattern in the numbers.
Okay.
And it had 70 plus 50. He did it on the abacus. It's 120. And then it had 70 plus 53. Oh,
I'm sorry,
okay.
say that again.
So
70 plus.
plus 50.
Okay.
So he did 70 plus 50 on the abacus, which is 120.
Okay.
Well, then the next problem was 70 plus 53. So what he did is he had the 120 there, and he just added the 3.
Okay. Good.
And then it had 70 plus 63. So he had the 123 and he just added another 10.
Right.
So he just realized the pattern, and he's still you're still kind of doing this mainstream math, but he is utilizing the abacus, with the problem. He didn't start over and do 70 plus 53 or 70 plus 63. He just realized what he needed to add in the ones place for that particular problem.
It's exciting.
I think that's really good. I think that he's showing number sense.
Yes.
He's
Yeah.
recognizing the pattern, and
Good.
then he's also, doing the strategies that you would do on the abacus,
Yes.
because 70 plus 5 is plus the 10 minus the 5, and that's what he
Yes.
did on there. So I was just basically taking her strategy there and just trying to just abacus it or whatever.
Good.
And so
That's
if she's
fantastic.
yeah, so she's saying +2. I mean, she's showing the picture there,
Yes.
but then we know, because we've been doing what that for 38, and you're looking at the second number. Well, we know that 8's partner is 2, so you're going to go 38 plus 2. You don't have enough beads to add the 2, so you have to plus the 10
Yes.
minus the 8.
Great.
So, and then they have the next one where they do 38 plus 70. You're doing the same thing. In my book, in that picture that I sent,
Yes.
I think I circled and put an arrow with where they show 8 of them are colored red and 2
Yes.
are colored green. That automatically tells you that it's partners right there.
Right.
It
was
I think I showed you a picture of it, because it has a picture where it says the pretend store, where it has the skate and the wheelbarrow and the scooter. That's what I sent you.
It was this one. Yeah. Let me pin it. How do I?
So I guess my goal would be, because it would be like, so what? So why are you doing it this way? Okay, my goal is just basically taking what she has and knowing what I know.
Yes, and abacifying it.
And that's what I'm doing.
Yes.
So yes, the shortcut way would be 40 minus 38 is 2. But that's what I was doing.
Got it.
Okay. So that's what I would hope that I was trying to explain. So if her first step is how many ones to get to the nearest 10, is another way of saying, how do you make a 10?
Yes.
You've kind of practiced that, and then we know that, and then the problem might get a little bit more challenging. I mean, because they had 42 plus what equals 200, and maybe
42. Okay, 42 plus something is equal to 100.
200.
200. Okay.
Yep.
Okay.
Well, the answer would be 158, but just yeah. So that's what they had there.
Okay.
So I mean, you could basically go up to 50, and then I could see where it's that big of a number, you would probably want to go and try to subtract. But yeah, so that's what I was doing on those problems.
Oh, okay. Got it. So you're on the right track. Because that's what I would do, is I would completely abacify it and figure out how to make it how to make it an abacus way.
Yeah, and so I can see where you're saying 200 subtract 42, and I had sent another video where I'm like, I'm still stumped when it has those zeros. I keep on forgetting where you're supposed to go because I had sent another problem.
Yeah, so I saw the other problems, which was okay, so yeah, so finding the missing add-in, and then the other one was $36 was, and the clerk gives you $36 and the clerk gives you $100,
Mm-hmm.
right?
Mm-hmm.
So the cat costs $36. So how much is the change back?
Mm-hmm.
If it's 100, then what we do is we take away 36.
Mm-hmm.
So all you got to do is take away the 3, take away the 30 on the tens.
Well, you have to subtract the the 1 and add 7.
Yes. Minus the 1, add the 7.
Well, now you have to you see, that kind of sets you up already, huh? So
Yes.
subtracting the 6 is going to be pretty easy because you've already added 7 there. So then minus the 6 is minus the 10
Yep.
plus the 4.
Yep.
So then you're going to get $74 worth in change.
64.
Oh, sorry. Yeah, 64. Yeah.
Right. But see, you could do it the other way. You could start from the ones place if you wanted to. It'd still be the same. But now what we're doing is we're going to chain it.
Oh, yeah,
This
you
is why we're
said that
chaining.
before.
Yeah. So if we did 6 from here, it's still the same thing. We're going to add the 4, and then here is my minus 1 because this is 1, 0, 1, 0. How do I minus the 1 here?
You have to go to a place where you can minus it, which is the next one over.
Right. So that would be minus the 10 plus the 9. Minus the 10 plus the 9. What? Yep. And then take away 3.
Now,
So
why do you call it chaining? Is chaining the same way? Because with that 100, we know we can't take away 6. So, oh man, I'm almost forgot. So you basically change the 1 to 0, and then you have 9, and then you have 0, right?
yes.
So
So
is
I'm
that
thinking about chaining because this turns into, because this connects the 10s to the 1 right here.
okay? I think you kind of said that in your book too, but
I did, but I called it a 2-step, and I'm changing the verbiage to say chaining because we may not necessarily just need to do this part here. We might need to actually make this one a +4 is equal to plus the 5 minus 1. So I think chaining makes it more sense because it's not necessarily just 2-step anymore.
so is chaining the same as regrouping? Is that what you're saying?
Yeah, adding the 10 and minusing the 10 is it all. Adding the 10 minus the 10, adding the 5 minus the 5, they're all regrouping. If you
Okay.
really think about it.
So what's rechaining? What's chaining then?
Chaining is when we combine the +5 and the minus 10, the +5 and the minus 10, or we combine the minus 10 with the +5. That's what chaining is.
How did you do that with the 100 minus 36? Because I only see the +10. Where do you get the +5 part? In that problem.
There was just a hypothetical.
Oh,
This is hypothetical. Yeah.
Abstract. My brain's not in an abstract mode right now. Holy cow. Okay, yeah. Okay.
So what I'm saying is depending on what the number is, we could
Right.
like if it was
Do a problem where there is a 5 and there's a 10. Because
okay,
that one isn't it though.
okay. So so this one would be hold on just a minute. I'm sorry. I have to think about, I think it'd be like 103 minus 36, right? So we have
Okay.
103. Take away 6. Minus 6 is what?
Minus the 10
Minus
plus
6
the 4.
equals minus the 10 plus
Plus the
the
4.
4. Cannot plus the 4. So what do we do? Plus the 5 minus 1. Plus the 5 minus the 1. And then minus the 10. Minus 1 is equal to minus the 10 plus the 9. Minus the 10 plus the 9.
Okay, do that again. How we couldn't do plus the 4. Oh yeah, because the bottom beads. Okay, so
Right.
can't you just plus the 5 minus the 1 right
That's what
on
we
there?
just did. That's what we did. That's what the chaining is.
Oh,
See, we're chaining. We're adding more to this 4. We're substituting.
oh, and what did you used to call it before?
Two-step. Yeah, I called it two-step. I called it two-step, but then I noticed it can be more than 2 steps. So the initial starting was 2-step because we would do like 7 plus 7, right?
Yeah.
7 plus 7, that would require 2-step. But then when it gets more, then this no longer is 2-step. So that's, I think chaining sounds better.
Oh, I see. So when the problem is bigger.
When the number, it depends on the number. It's not the problem because it's the same problem and the same amount of digits.
Okay.
Right? So it's not hi Abram, it's not the problem. It's depending on what the digits are and how it gets the thing.
Okay.
So that's why I think chaining sounds better just because it's no longer 2-step because this is 1 and then this is another 1. So there's 3 steps right here.
Okay. So the first one we did was minus
The first step
6.
we did is minus the 6.
Okay.
Right?
Yeah.
Then what we try to do is we try to add the 4.
Okay. So the second
But
step
couldn't
was
add the 4, but we couldn't add the 4, so we had to do the plus 5.
okay. And
Right.
then you have the last step is minusing the 3.
Minusing the 3. Yeah, that's not a step. That's still the question.
That's still
The next
question.
step, the third step was minus the 1.
Okay. Oh yeah, you minusing the 1 in the hundredths place. Okay.
Mm-hmm.
And minusing the 10 plus the 9.
Yeah. So that's
Okay.
why I was calling it chaining instead of 2-step because this is no longer 2-step.
Okay. Okay. Yeah, I see what you're talking about.
Yeah.
Makes sense.
Thanks.
Yeah, and then you put the chaining in your book.
Yeah, I'm gonna update it and call it chaining.
Oh, so you're not gonna call it a 2-step
2-step?
in your book?
No, I think I'm gonna change it to chaining. Maybe, yeah, because when the numbers get bigger, it's not gonna make sense.
Okay. Yeah, sorry, I'm yawning.
She got tired.
I hear that.
Okay. Yeah,
So,
and
but
we've been doing that all along, right?
yes, we've been doing it all along. I'm just changing the vocabulary on it
Okay.
because in Abacus world, what they did is they called this mixed formula, but
Yeah,
it
and you
only
said you didn't
pertained
like
to
it.
yeah, it only pertained to something like this. That's what they call a mixed formula. But I'm extending it because you can change it.
Oh well.
Yeah. But I like that the fact that you're abacifying the workbooks, and that's exactly what I would do.
Yeah, that's why I was asking your advice. on that
I
problem.
see. I see. I see. Yeah, no, you're on the right track. You're
Yeah.
absolutely on the right track.
Yeah, so maybe when you go back on it, well, you'll see what I'm talking about and what because I gave an example and
Yeah,
then
yeah, yeah. I was
it,
looking at it, but I wasn't sure. So, and that's why I enjoyed like these talks because I wasn't sure where the what the goal was. Like, was trying to do something about it, or was I, you know what I mean? But if you're trying to abacify it, then you're on the right track.
okay. So my question would be when I put in a question and how do I
Abacify it, abacify,
abacify this question, Lynette?
abacify. It's
Abacus.
abacify,
Uh, how do I
abacify.
abacus it or something? I don't abacify. I don't know if that
How
is
do you
that even a
abacus?
word.
No, no, that's a made up word that I made. So,
Okay.
so what the question is? How do you abacify this?
Yes. Well, no, well, not that one. It was basically the
The
one.
missing ones, these
Yeah,
ones,
the
right?
missing addend. Yeah, because that's a different skill set of doing the problem. So I wanted to know how do you and so I thought, well, there you do your partners attend, and then after that, you just
Yeah, yeah. See, the biggest thing is knowing what you're trying to do because you're always trying to make this a 10. So you're always trying to make it to the nearest 10, either up or down, right?
mm-hmm,
Depending if you're adding or subtracting,
mm-hmm.
right? So
We're adding,
even
so
yeah, so we're adding. So you want to round up to the 70. So you're doing exactly what I would do.
yeah.
That's how I would abacify it because I would take this here and figure out how to make it a 10. So
So
there was that one question, like this one here,
yeah,
right? Well,
yeah.
how many, how much do you need to get to the 10 over here? How do we make this a 10? How do we make this a,
Yeah,
um,
how do you make that a 10? Well, you
yeah,
know that not because in your books you always have us do okay. Well, 9 and 1 is 10, 8 and 2 is 10.
yep,
You're always talking about that,
yeah,
and so we automatically know okay. Well, 9 and 1, so
yep,
we put the one down
yep.
in the
And then
ones place, and
yep. And then that becomes 30 and it'd be the
yep.
same thing. Yep.
So
And then from here you would count by whatever, count by hundreds or count by whatever, right? To get to here. I wouldn't count
oh,
by
was
tens.
that
I would count by
130?
yeah, it was 130. I wouldn't
Well,
count
you already
by
know you know that it's
it'd be counting by hundreds, right? So you had the 29. I
mhm.
know to get to 30, I have to plus the 10 minus the 9. And then here, I just add the 1 here,
Yeah, you said yeah.
right?
Yup.
So
There we go. Uh-huh.
yeah.
That's what you were doing.
So you're doing exactly what I would do. So here it's like 42.
Mm-hmm.
Well, how do I make this 42 to the 10 to the nearest to how do I round it up to 10? The how do I
Do you
how do
think
I go up to
rounding
10?
well, rounding up
Round this up to the
I
nearest
take
10.
it takes away the making a 10 when you say round up though.
Yeah, you could say make a 10. It wouldn't it wouldn't hurt to have different vocabulary either though.
Right. Because you know the partner to 2 is going to be 8. So
Yeah, exactly.
you'll be 50. So
Yes.
you put the 8 there cuz you're trying to solve part of the what. Okay?
Yes.
So you put
Yes.
the 8 in the plus 8. You put the 8 in there on the
Oh,
ones
here?
place. Yeah, cuz that
Yeah.
you already know that. So now we're doing 50 and
So
20. So
yeah.
then
So then it becomes 50, right? So
yeah.
then you have to figure out, well, how many, so that'd be, and then you have to figure out, well, I got to get to 200.
Yeah.
So you can either subtraction or you can count by tens, depending on how they want to teach it, depending on, but because you see the number pattern,
Oh, this one's a little bit trickier.
it's not, why would it be tricky?
Well, it's basically 158.
Yeah, but why is it tricky? Because we would count by 60, 70, 80, 90, 100. And you count by twos.
So that's how you would have done that one, huh?
That's what I would probably do. Either
Um,
count by tens, right? Count by tens and figure that out. Yeah. If you don't want to do subtraction.
Okay, I'll have to think
Yeah.
that through because I still have to put the 1 and the 5 there.
The 1 and the 5. Yes.
Yeah.
Yes.
So how do I do that? Once
What
I
do you
got
mean?
50, how do you do that?
So
I
we
think
go back.
that's
So we have this,
uh-huh.
right? To
Yeah.
get to the ultimate goal is to 200.
Yeah.
Oh, sorry. The ultimate goal is to 200. So we know there's going to be 8. So that gives you 50. So then we know what? We know that. So now here's the thing. Don't worry about this part here. Don't worry about the extra zeros. How do we know we get from 5 to 10? 5 to 10 is another 5.
Oh, okay.
Right?
Mm-hmm.
So that would be the 5 plus the 5 minus the 1, or plus the 10.
Mm.
So that would be another way, right? Because in Abacus, we don't necessarily need to pay attention to the, because if we had 50, right? Now, how do we know what? We know 5 plus 5 plus 5 is equal to 10.
Yeah, it's just it's just solving for x is what mainly because I think we've gone
Yes.
away from that, and
Yeah.
so, but yeah, okay. I just I
But
see what you're
exactly.
saying,
Yeah, but exactly what you're doing here is, find or make a 10, round up to 10, find the 10. Yeah.
yeah, because see, I already did the ones, and now I'm doing the tens.
Yep. Yeah. So you did so again, exactly. You did the ones, that's the ones, and then
That's
you do
the
the
8,
tens.
yeah.
Yeah. So
Right.
how many fives does it make to get a 10? It takes 5. So you do it again. So this is where you understand the place values as well.
Yeah, and then there's the 158 right there.
Yeah, exactly. Exactly.
Okay.
Exactly. But it's a different way of thinking, but still within the realm of Abacus.
Yeah.
Yeah.
I might have made it a little difficult, but I don't know. Aaron goes, yeah, I did that page too, and I'm like, oh, I was gonna try to show you that, but he already filled it in.
But that's fine though, because
Yep.
now you're seeing it as a puzzle for you to figure out, but it's one of those things, right? Like it's one of those things that we want to show them how we did it, but ultimately it's how do they figure it out?
Yeah,
You know,
he figured it out, which was good.
which is
So,
exciting because then maybe what you guys can do, instead of you showing him, maybe you guys can actually have a discussion. How did you find out? This is what I did. And so now you're having an actual math discussion as opposed to you teaching him.
True. Yeah.
Right. Just like what we're doing right now, we're having a math discussion as opposed to me teaching.
Yeah.
Trying to solve a problem. But like we're actually having a different discussion of like, what does this mean to find the numbers? But because he understands, Abacus, and you're trying to abacify it because you understand Abacus, it's a lot easier than the different strategies that they're teaching.
And ladies,
Maybe. It might be.
Yeah, I feel like that they keep introducing all these different strategies that it just doesn't.
Well,
because
I just created one right there.
Yeah, exactly.
So, and it might be good, it might not.
But you created your own strategy as opposed to memorizing somebody else's strategy that you don't understand how they got there. You know what I mean?
I understood how she got there, and I just took what she had, her 2 steps,
Yeah.
because she was basically saying that she was basically saying, how do you make a group of 10? She was basically saying the same thing
Yes.
as how do you make a 10?
Yes.
And then how many tens do you
Yes.
have once you've created that,
Yep.
42 plus 8? How many tens?
Yep.
Well,
And
that
that's it.
part, I didn't know how to reword
It,
that part, but
yeah. Sorry, Tammy, you were saying?
I'm lasted as long as I can today, so I'm gonna go ahead and leave,
Oh, okay.
and I will talk to y'all next week.
Okay, sounds good.
All right,
Thank you.
bye.
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 Yeah. So that was the
Oh,
thing. It's like, even though you're trying to make a 10, you could say try to make a 10 in the tens column. Or what you could try to do is say, okay, well, if you know that there's 5 here, how do I know how to make another 5? So in Abacus, we don't talk about place values because Abacus does it for us. So instead of saying the nearest 10, if you want to stay with the piece of paper, you could say the nearest 10. Or if you want to go with the abacus, you could say, okay, how do we get to the nearest 10 over here?
mm-hmm.
Plus the 10 minus the 5. And then you need to get 200, which is just
Okay.
20.
Yeah.
So, but like, but for like abacus, when we do it, we only look at any two columns.
Okay.
And that's another nuance that I've noticed with abacus. So
Mm-hmm.
like the issue with the mainstream is because everything is written on paper, we need to pay attention where all the places are. But
Mm-hmm.
in abacus, because there's restrictions and boundaries, you can't necessarily mistaken your place values.
No, but like you said before, where you have an X, you're pretty much doing a little bit of an algebraic
Yes.
equation. And
Yes.
so then you just automatically go, like what you said, is going, okay, we take the 65 and we minus it, and then you're still doing your subtracting.
Yes.
So, it's, I mean, you could kind of go and do what she's doing and kind of abacize it a little bit, or you can just go into the traditional subtracting. But I know that if you have a test or something like that, being able to understand what they're saying, and then using the abacus to your advantage is what the goal is.
Yeah.
My only thing is that because we're doing the abacus, I've almost forgotten how to do it the old way, where you go and minus this, change this number to that number and
But
stuff.
but
Almost
that's the
forgot.
thing is like, do we need to? Because that's extra energy that necessarily might not can be used elsewhere. So like,
True.
I
And I
like,
might have, yeah, I might have made extra energy with this.
yeah.
you know.
So, and that's the other thing is like, I was like thinking about it, and which really goes into the point of your question about cognitive and working memory,
Yeah, cognitive overload. With
cognitive
that,
overload. Yep.
yeah, because I was watching a video. I'm always watching videos and stuff like that, and so I was watching a homeschooler, and right now we so we're always worried that, I mean, it doesn't matter whether you're in homeschool or whether you're in mainstream,
Yeah.
public school. The problem is, are they falling behind? And
Yes.
so basically, the words that came out was, now there are not all curriculums are equal.
Right.
I get that. There are going to be some gaps, some things that they don't cover.
Right.
However, what was frustrating to me is this rigor sense of feeling. I mean, I have to admit, because Abram has been able to go the pace that he has developed a number sense. Whether he's using the abacus or not, he's developed a number sense. And then things now are clicking.
Good.
But what they want you, the one lady is saying, well, I want my children to know be able to know their number facts, and they need to be able to get it under I don't know 30 seconds or less. And I'm thinking,
Yeah.
why does there have to be a timing for this?
Oh,
If
okay.
you
Yeah.
if you understand the patterns,
Yeah.
I mean, it's kind of like how you said that your sons they automatically knew what their fingers were doing.
Yeah.
There's no, I'm sure they got tested too in school, but there's
Yes.
no, so why do we have to have the pressure of all this testing and making sure that you can, because in school, they would have to do 100 fact problems. Is it either, was it
Yep.
50 on each? And they had
Yep.
to do it
Whatever.
under 3
Yeah.
minutes or less or something like that.
Yeah.
Why do you need to be timed? Why don't we understand the patterns and things like that? Because yeah, why? And there's such a pressure that we have to master the facts, the number facts, the math facts. And then what was really cool is when you talked about how you showed a gentle way of knowing your times table by just starting off small, taking 2 digits and times it by 2. You
Yeah.
could do 45 times 2. It doesn't matter because you know that 2 times 4 is 8. You
Yeah.
know that 2 times 5 is 10.
Yeah.
And you know that that's 90.
Yeah.
And then it's just a gradual thing. And I think that's part of what mastery is. I mean, she had some other things about spiraling, and that is you take a dab in one thing, and then you spiral and you learn a new thing, and then you come back. And so
Yeah.
you, by going and doing some repetition, but I think with the abacus, when you're doing that repetition, it starts to become automatic. You're not taking a flashcard and saying, okay, what's 9? Most of the time, when they do 9 plus 5,
Yes.
what I was told is that, well, 9 always wants to be a 10.
Right.
So you're taking 1 from the 5
Yep. You go backwards.
and you go backwards. And
Yep.
so that's why you get 14.
Yep.
That's how I was taught with that, because if you go 9 plus 5, it's plus the 10, and it is minus 1. If you think
Yep.
about it,
Yep.
that's what they're doing. They are taking 1 from the 5 to make the 10, and you're subtracting 1, and that's why you have 4.
Yeah, but for abacus, we do it the other way around because we see it. We see this on the abacus. We have to take from here to add it to here. That's the difference.
Okay, do that on the abacus. So you got 9.
9. So
Plus
we have
5.
9 on the abacus. We know in our brain we want to have the 5. We know 5 plus 5. In our brain, we know 5 plus 5 is equal to 10. So we have to get the 5 from somewhere, take it away from the 9, and that's how to make a 10.
Oh, because your 4 is already there.
Yes. See, and that was the thing. Like even when we do the 6, I know 4 and 6 are a 10. All I need to do is find the 4 from somewhere, take it away from the 9 to plus the 10. It's the difference. It's the different way of just seeing things. So we know 7 plus 3, make a 10. I know 3 comes from somewhere. Where's the 3 going to come from? The 3 will come from the 9. I could see from my 9 that I have 3. 1, 2, 3. And I take away the 3 to make my 10.
Do that again, one more time.
So I know 2 and 8 makes a 10. I know this. Down pat, I know. Where am I going to get the 2 from? The 2 will come from the 9 because I could see it. Because I could see there's 2, 1, 2, I could take it away. And that I've made my 10.
Okay, now do 9 plus 8.
9 plus 8, that's what I did. 9 plus 8. 8 I know 8 plus 2 is equal to 10. 8 plus 2 is equal to 10. 2. 2 has to come from somewhere. 2 will come from what I can see. I could see that I could take 2 away from this 9.
Oh yeah, because plus the 8 is plus the 10 minus 2. Okay, so
Yes.
you're visually saying that. Oh, okay, okay.
Yeah. You're visually seeing that you could take 2 away from this 9.
Okay. Okay, I see what you're saying.
Yeah. But see, the difference is in mainstream, you're given, in mainstream, you're given 9. The difference is what? You get these blocks, you get the 9 like that. And then you have 5, 1, 2, 3, 4, 5. Because you have it like this, they're combining it together and they're regrouping. That's what they do in mainstream math. But in Abacus, we already know what the structure is.
Mm-hmm.
If we know what the structure is, why do we always have to always group and regroup? Why can't we just use the structure that we know and put it in? I know that this is 5. I know I just need to take 5 from my 9.
Mm. Yeah, there's your 4.
There's my 4. So
Okay.
it's very nuanced and it's interesting that you're going down this rabbit hole because this is the revelations that I have made.
Oh, really?
Yeah. So like in the beginning when I was teaching, very, very beginning when I was learning, I was like, okay, we are going to plus the 10 minus the 2, plus the 10. Why do we? And then it goes back to why are we going to minus the 2? Because I can, in my brain, I know my math facts of 10. I know hands down 8 and 2 is a 10. Because
Yes.
I know this pattern, I know I just need to take in order to make.
Yep. That's kind of what I was doing with the 65 plus or whatever.
Yes, exactly.
That's what I was
exactly.
doing.
So when you're doing the 65, it's good, but then the next thing is you can do the same thing. You do it with the 1s, you do it again with the 10s.
Okay.
You know, that's what I'm trying to say. If you do it for the 1s, do it with the 10s. But for Abacus, we just look at, for Abacus, you see, we only look at 2 columns, whereas on a piece of paper, we look at the whole thing. And I'm like, oh, that's too much. But if you notice,
do you do the 10s? How do you do the 10s then with it 65 plus?
it's the same thing. It's the same thing. So we did 65, right? 65. Yeah. You did the 1s. So now, how many times? So now we're at 70, right? 70, 70. But how do we make 10 to 7? How do we get 10 to get to 100? Or what was the question? 7?
Well,
Yeah.
the 65 plus x equals 70, we already know that it's 5 more. But if you do 65 plus x equals 80.
So then how many times? Okay, so we did, so then 7. How many times do we go to 8? Yeah. 7 take away 8. 7 take away 8 is 1.
Okay, do that again.
So we have 70, right? Cover it up. 7 minus 8 is what?
You mean 8 minus 7?
8 minus 7. We just add the 1.
Yeah, that's 1 more time.
Right. But we don't worry about the place values, right? Because we just worry about our columns.
Mm-hmm. Mm-hmm.
Right.
Okay.
Yeah. So when the numbers get bigger, I don't know. I'd have to think about that one. But when the numbers get bigger, just take it 1 column at a time.
65 plus what equals 110? That one.
Oh, let's try that.
Okay. So you give 65.
So 65
plus what?
Something is equal to 110, right?
Yeah. Mm-hmm.
So same thing. How many times do we get to 5? So we know plus the 5, right? Then we get 70.
Mm-hmm.
Okay, fine. So now instead of 70, we do 7 plus what is equal to 11?
Yes, 4.
So
Because we
how do
already,
we get, yeah. So then this would be a plus the 10 minus the
minus the
3.
minus the
3. Minus the 3 is minus the 5 plus the 4. Oh, wait. What am I doing?
no, you did it wrong.
No. I did it wrong. 11. Oh, yeah, wait. So how many times do we get to, yeah.
So you have
So,
70. So you have 70 now.
yeah.
So put
So,
70 back.
70. Yep, 70.
And
And
then
then
how many 10s to get to
110.
110?
Mm-hmm. Or how many ones to get to 11?
Oh.
Because we're only looking at this, right? And you do it
Yeah.
again. Well, I know, right?
Yeah.
So how many? 9. What is it? 9? Now just like, it's just kind of like all over the place. But yeah, like how many times? So we need 7 to make to 10, right? So 3. 3 to make to the nearest 10. So this becomes 10. And then you add the 1.
You couldn't do 4?
You could do 4. You could do 4, but you always want to figure out how to make a 10,
Mm-hmm.
right?
Mm-hmm.
Everything that we try to do, we always try to make a 10, doesn't matter. So then we get to 100, then you add the 1.
I see what you did.
Mm-hmm. Mm-hmm.
Yeah, you did do that, the same one.
Mm-hmm.
Because 7's partner to 10 is 3.
Mm-hmm.
So you get 100, then you add the
Mm-hmm.
1
Because
more.
what the explanation was to do it in multiple steps, right? So
Yeah.
why can't we do it in multiple steps? Same thing. But we are always on Abacus, we're always focusing on the 10. The
Mm-hmm.
bottom number always needs to be making a 10.
So let's do 65 plus 100.
65 plus 100.
Oh,
Plus
sorry,
100 or
65 plus what?
okay, 60, yeah, got it. No, you're good. So same
Uh-huh.
thing. This becomes 5,
Yep,
right? This becomes 70.
yep.
So then how many do we get to? Same thing. Plus
We know,
3.
yep, because, yeah, okay.
So it's always it's always going to be the how to make a 10, no matter what. In Abacus world, to abacify anything, always figure out how to make a 10 or how to make a 5. Those are the two things that you need: how to make a 10 and how to make a 5 to abacify.
Ah, so then when we do that 42 plus what equals 200, then how would you do that one?
Then I'd go to 5, right? So we said 42.
Mm-hmm.
42 plus
Plus
something is
what?
equal
Yeah.
to, I don't know, 30, 80,
200.
200.
Yeah.
So we do 200,
Yep.
right? This one, if you were to really abacify it, this goes to 5. So we need 3, right? Goes to 45. And then from here, it'd be 5 plus 5 would equal to 50. And then from here, it would go to 200.
I would automatically do the 10 part because then it's one less step.
Right. You could do that too.
Yeah. Yeah. I would do that.
Yeah.
So I would do, so.
It would probably be plus the 8 instead of plus the 5. I think.
Yeah. Yeah.
I
Plus
think,
the 8. Yeah. It would be
yeah,
plus
it'd
the
be
8.
plus the 8. It would be plus the 8 instead of plus the 5 to get to 50.
Yeah.
Yeah.
And so then.
Yeah, but I'm just saying that if you know your 5s and your 10s,
Mm-hmm.
right, then it'd be an easy thing.
Because on the abacus, it would show you that you're trying to get 158 in there.
Yeah.
It would show you the 158. So, okay.
Mm-hmm. Mm-hmm.
Yeah. Okay.
So, but yeah, it'd still be, yeah.
So
It's just that,
so you
yeah.
go 42. You put 42 on the abacus.
42, and then
Okay.
8. See, and then you'd have to,
Yep, that's
right?
8, that's 50,
50.
yep. So see, there's your 8 and there's your 5, and now you're adding, on the thing.
Yeah.
Okay.
Yeah. Yeah. But we're always trying to either make a 10 or make a 5, depending on what we're trying to do.
Okay.
Right?
So you would have them make sure that you write the 8 and then you write the 5. And then you created how do you get to 200 after that?
Well, they can either count by 50s, right? Or they can count by 10s or however they want to count to. I mean, now we're getting into like, do they understand their number lines and progression and on, right? Where it is just another way of doing things, or they might already know how to subtract or do beginning parts of algebra, because this is essentially beginning parts of algebra. Trying to figure out what this x is the beginning parts of algebra, which goes back to, we already started doing that in Abacus world when we say plus the 4 is equal to plus the 5 minus 1. Doing this, or even understanding that plus the 4 is equal to plus the 10 minus 6, having this concept to substitute is already a step forward to what they're doing here.
Okay, so let's do the 42 plus what is 200, and then let's subtract the 42.
What do you mean? So we have 200.
Mm-hmm.
So
you have 200 minus 42.
200 minus 42.
Mm-hmm.
So let's do this first. Oops, sorry. Let's do that first. So we have 200 on the abacus.
Mm-hmm.
We do minus the 4 is what?
Minus the 4 is minus 10 plus 6.
Minus the 10 plus the 6. Right?
Yeah.
And then we minus the 2. Minus 2 is what?
Minus 2 is minus the 5 plus 3.
No,
no,
because we cannot minus. Yep.
Oh, you're right. Sorry. Minus 10 plus the 8.
Right. Minus the 10 plus the 8.
Yeah, I can see what you're talking about. Yeah, that's probably a lot easier. But yeah.
Right.
Okay.
No. But what I'm saying is it's good to go through what they are doing.
Yes.
And see how it connects to how we do it.
Yes.
But because Avram and you have a strong sense of numbers, then it's a lot easier to see how they're all related.
Mm-hmm.
She's teaching you a strategy for those students that are not familiar or have strong number sense.
You think so?
That's the difference. Because they're doing it on paper, they don't know how to make a 10. They're not always saying make a 10. They're saying, they're always saying, 5 and 9 makes a 10. So that 5 and 9 makes 14. We have to memorize that. 6 and 9 makes 15. We got to memorize that too. Whereas in Abacus, it's always make the 10.
Yeah, it's always make the 10 out of 5. Yeah.
It's a different way of thinking, and it's more it's more efficient, but 2, takes less energy. And that's where it goes back to, I think what they're doing in mainstream is they're providing all these different strategies when there's really just a very simple way of trying to get to where you need to go.
Mm-hmm.
Because
that's why I thought of your formulas, because I mean when they were talking about rigor and
yes,
I know your facts and
yes,
then I thought of your multiplication book. So
yes,
how you had a gentle progression.
A gentle progression. But see, the thing is these are the core and the fundamentals. And if you know how to manipulate, this is where Abacus becomes number fluent and number flexibility. Because we can do this, we become flexible in what their questions are. So when they start saying 42 plus 40, this right here.
What? Yeah.
65 plus 10, 65 plus 100, you can figure it out. Mm-hmm. Through their ways, or understand what we're trying to accomplish. Mm-hmm. Up to you.
Yeah. So I just hope that I didn't, because I'm sure Tammy wanted to ask some questions. I don't want to monopolize that part. So to be able to give her an opportunity to do things too.
You're perfectly fine. You're absolutely. This is exactly why we have the office hours. It's because I wanted to make sure that we talk about how we think about math.
Mm-hmm.
She just came out of her surgery, so she's not really thinking all that straight anyways.
Yeah, I know. She didn't look like she was very comfortable. So, or
But
tired. So,
so
yeah.
going back to this, like I feel like they're telling you all these different strategies, like this is what you do and all that. Whereas in Abacus, it's like you only need to know the fundamentals and you're set.
Yeah. Yeah. And I was able to use that. So, yeah,
Yes.
I don't know how Avram did it. All I know is that he got every single problem right, and I think he still saw that there were patterns in the problem. So,
Yes. And
so
that's the goal. The goal is to be able to um the goal is to be able to see the different ways to get there. To you can even to abacify it, right? There's many
yeah.
ways to get there,
Hmm.
but you don't need to memorize all of the strategies that's being taught.
Yeah, well, that's where I think it's a cognitive overload for all, and then they're tested on
Yes.
all these different strategies, and if they don't have
Yes.
it right, then they have it
Yes.
marked wrong, and then they have
Yes.
no desire to do math anymore,
Yes.
or they
And I
don't like
think
math.
and I think that's what the problem was. So like I was talking to my friend and we were just talking about how um they're talking at second grade, some kids have limited executive functioning. And so, what is executive functioning? Executive functioning is like paying attention, remembering instructions, switching tasks, understand where you go for it, talking about working memory, cognitive flexibility, as well as like, control, right? Self
Hmm.
control and all this, right?
Hmm.
And so, Abacus, because you're restricted, not restricted, but because there's restrictions on where everything goes, the sky's not the limit. We have set boundaries that we need to know we can use.
Hmm.
Whereas on a piece of paper, if it's a blank piece of paper, you could draw anything and
Hmm.
it wouldn't even make sense.
Hmm.
So there's a lot of nuances to what you're saying, and a lot of like, yeah, a lot of what's being taught in mainstream, I feel like it is overload, because if you don't just choose one, how are they going to know what to choose? That one there's that one uh um situation where if you're given 100 items, you get,
Hmm.
analysis paralysis. But if you choose three things, you're always going to pick something. And I feel like that's what they're doing with math. In mainstream math, they're giving you all these 100 ways to figure out to solve a problem, but you just need to know one, and you need to know it really well. And I think they are
Hmm.
forgetting that,
Hmm. Yeah, because
right?
if you think about it, you're only really with all these different strategies, you're only putting a dab into it. You're
Yeah.
not really mastering probably
Yeah.
that tact, because then you're moving on to the next strategy.
Yeah. So it's a
So
strategy on strategy on strategies where on, yeah.
so
And
I'll be careful on that with Avram too. So
you
um,
could easily say, how do you use it with the abacus? And that would really bring it down to, here's how I do it on the abacus. And it
oh,
doesn't
how would
matter.
you do this problem on the abacus? Yeah, there you go. And then that gives him his his thinking going, and
Yes.
then okay. So
Yeah.
instead of okay, this new strategy, how would you? And then that, like you said, where we have okay, well, this is how I would have done this problem on the abacus,
Yeah.
and that's why you said a discussion. So
Yes.
yeah, okay. This is okay. I commend myself. I've handled this situation a lot better than I did the other one, but I also I think I explained everything and I was a lot more patient. So I'm proud of myself.
You're very good. You're very good. And also, we didn't interrupt you.
Oh,
That
okay.
was a big thing. And I realized that what we were doing is we were interrupting you because we were trying to explain how we were thinking, when I was just like, it should have been like, you need to explain your whole thinking before. And that was when I had started asking questions like, what was the point of
Yeah. What
showing
was?
these different strategies? Because I wasn't sure
Uh huh.
what the goal was. But if your goal was to abacify it, you're on the right track. I would totally be like to Avram, instead of saying these are the different strategies, I'd be like, okay, how would you abacify this? you see the steps that they do. How do you abacify it? I wouldn't even say different strategies. I would just say, how would you abacify it?
I love it. I love it. This is so awesome. Okay. So how would you use the abacus in this problem? I like
Yeah.
that. And
Yeah.
then, yeah.
And that would really solidify like, oh, okay. Because the biggest thing about the abacus is just how does the numbers work and how do they relate to each other? And because I like the whole, like, you know, you got to add the 10 and all this stuff. That's about, you know, thinking different ways. And that would be, how would you abacify that? Like, how does it work with the abacus? Always make a 10 and then finding friendly numbers. Abacus is all about friendly numbers, but we don't call it friendly numbers. We call it making a 10. You know what I mean? They have
making
their
a 10 or making a 5. Yep.
yeah, but they have like different terminologies for everything. And I'm like, there's a lot of words.
Mm-hmm.
But like, you know, doubles, near doubles, find the friendly, whatever. When you find the friendly, it's always the bottom number.
Yeah. It's the second number.
It's always the second number. And
Yep.
knowing that makes everything everything fits into the pattern.
Mm-hmm. Yep. I like it. I like it. Okay.
But you did very well. I do enjoy these discussions, and I really enjoy like you bringing into a spin on how everybody else does it, because that's what I do too. Is I also try to research on how everybody else does it and how do I abacify it. And my goal was always to how do I figure out how to abacify it, because you know it's, even though it's out there.
Well, the abacus is not necessarily at this particular point just used to calculate. It's used as like what you said, making a 10. It's going back to the principal foundation, like you said. So
Yeah,
and
yeah,
and then once I I know you've said that I've mastered it, but the person that I feel has really mastered it is Tammy, and I want to be where she's at. Because I can I feel like I'm slower than a snail. I have to.
don't
My-
compare. Comparison is the theft of joy.
It is. It is. But it just tells me I need to just, the more that I do it, the more I'm sure we make mistakes on the abacus because we're moving so fast. But your brain is what's making a mental note
Yes,
of what you're doing here.
yes. And because your eyes can see how everything is moving, you're going to start noticing
Noticing patterns.
patterns, but then you may not necessarily verbalize the obvious.
Oh, I like that statement. Hold on, I gotta write that down.
You're not going to be
said-
able to verbalize the obvious.
Why
So
is
just as we did 100 we just as we did 103, right? Minus 60 36,
yeah.
right? You in your brain said, oh, all you got to do, see, this is how I know you've mastered it, because you're like, all you got to do is plus the 4 plus the 5 minus the 1. Why couldn't you do that? I'm like, I did. But you already saw it and you knew it.
Okay.
Does that make sense what I'm trying to say?
Yeah, I'm just wishing I could be a little bit faster.
You no, but you are. You just didn't verbalize it because you already recognized that you could add the 5 minus the 1. You already knew you could do this.
Uh-huh.
The only difference was the timing of like, why couldn't you do it? And I'm like, but you did, in your brain already did it.
Oh, okay. Okay.
Do you see what I'm saying? Like, you're verbalizing it, but your brain is connecting a lot faster than how we speak.
Okay, so it's connecting. Yeah, because, okay, not to change the subject, but it's amazing how Abram was given the Imperial March. And the first time when he was trying to do the middle sections, one of the teachers, what the teacher said, go slow, go slow. And I
Yeah.
watched him go slow, and then all of a sudden he started getting the rhythm and he went faster. Now, sometimes what we do is we do just the opposite. We go so fast that we start messing up on our rhythm in our notes.
Yes.
And so
Yep.
sometimes we have to just slow back down. You've mastered the rhythm part.
Yes.
But slow down. You don't need to go so fast. I mean, he's played the Imperial March from the very bottom of the scale all the way up to the highest point of the scale.
Yeah.
And he still knows where his fingering is.
Good.
He knows what his notes are.
Yep. Yep.
That's so.
And that's the goal, right? The goal is to get it to the point where it's automatic. But there's understanding that happens to get to the automaticity. And that's the difference between mainstream math and what we're doing, is because mainstream math is like, they want you to just memorize and just, these are all the strategies and there you go. Whereas in, what I'm doing, what we are doing is we're understanding, why does it go this way? How else can we go to do this that we need to do?
Mm-hmm, mm-hmm, mm-hmm. And what you have done so well is you've verbalized it, because I printed off that one sheet where you when you were talking about it was in your second grade. You went through each step of the process of how to do. You have 9 plus 7, and you talk about how you actually show where you get the.
This.
Yes, that. Yes. Which book is that in?
That was book 1. This is book 1. I did it again for book 2. You have book 2.
Yes, you because you even say yes, you even say at the top, right there it says 3 beads, and you put notice there is no more room to add 3 beads to 7, and then you go, do you remember how to make a 10? Let's make a 10 asteroids on the belt.
Yeah.
And you said, how many asteroids are needed to make a 10 asteroids in the belt? And you're circling the 7, you're showing, and each time you progress with, and then you kind of complete, and then you get to the formula on the bottom.
Yeah.
That's cool. I like how you did that.
Thanks.
But then at the same time on the side, you're working the problems on the side on the abacus.
Yes, those are separate examples.
Those are
to show the same number.
To show the same number. But you took the time to, and that's the part that I want Avram to do, is slow down, read that part, because what you're doing is internalizing what we're doing.
But he's young enough that he's just going to know it.
But he probably don't want to read it.
He probably doesn't want to read it.
And that's okay? Is that what you're saying?
That's okay. That's okay. Because he doesn't have because don't forget, like, as an adult brain, we're always asking why. He may not be at that stage where he's asking why.
But I want to teach him to ask why. He's starting to, I have to admit, he is learning how to ask questions.
Good.
Which I think is really good at this age, even though our brain is not really thinking analytically as much. It's not thinking as concrete. Yes. It's very
abstract.
No, sorry. Your brain isn't as abstract at this age.
Oh, right.
It's more concrete. And so we're helping him to ask questions so that his brain can become abstract. But sometimes you have to just, what's the word?
It will get there when he starts asking. When the numbers get bigger, he's going to start asking those questions.
Okay.
Right? So that you get to the point where when the numbers get bigger, they'll be like, oh, wait a minute. What am I doing here? So that's where the critical thinking happens, is when the numbers get bigger and they're like, wait a minute, what am I supposed to do here? Oh yeah, that's right. Make my 10.
Okay, I see. Okay.
Yeah. So I wouldn't do it when he's learning, because you need to learn it and understand it and then you can ask the questions.
Well, that's where you're building up the foundation.
Yes, but you don't ask questions when you build the foundations. You ask questions after you build the foundation.
Why not? Why not during?
Cognitive overload.
Oh, yes.
Cognitive overload because your brain doesn't understand what's going on. So knowing, understanding to mastery is when you can start asking all these questions, because then you have your foundation to be like, oh, this is why it's doing, this is what we're doing.
Otherwise, you're just doing things just to do it, and you're doing it not knowing.
Yeah. So understanding, so knowledge, know what it is, understand it. Mastery is where you ask the questions, because mastery is when you figure out where everything fits.
I love it.
Okay. So don't ask the questions now. Ask the questions when he's mastered. Why did you do it this way? Why are you going here? What is it that needs to happen? Because now he has the foundation to ask that.
And he can answer the question.
And
that's when you've, so then what are we really doing in math then? If the kids, because if the kids don't know how to ask the questions, then they're just going through the motions and doing stuff.
Yep. And that's where the memorization happens. That's where all the, and everybody's like, this, do the different strategies, you know, every child will find their way, blah, blah, blah. Every child will find their way to figure out how to do that. The problem is they don't get to that point of, they never get to the point of mastery. So the way I built my books is, you know, because you've seen the plus 10 books and you've seen it's all just regrouping, right? This is only about regrouping. This is only about making the 10, this to the point where it becomes mastery level. And then they can ask the questions, well, what else can I do with this? It's the same thing with my book too. All my books is to the point of mastery. The goal is to do one thing really well to the point where you become a master of it, and then you can ask your questions.
I love it. Okay. There's such thought in there. See, there's a wisdom. I like it. I love it. So cool.
Thank you. I do appreciate it. There was a method to my madness, and it's interesting when it comes to fruition, you know, when it comes to like in play. Like it's been sitting in my head for quite some time now. But this is like 2-3 years of just like trying to figure out what is it that I'm trying to do, if that made sense. So like when I first started learning and, you know, had the learning center, I didn't ask why, but right now it's like, well, how come Abacus cannot be there? How come Abacus? It's because we have different words. Nobody's made that connection. And that's what I'm trying to do here is I'm trying to make that connection. So it makes a lot more sense in the eyes of Eurocentric math.
Oh, okay. And so my example of today
is perfect.
Okay.
It's perfect because it's exactly what we're trying to do. It's exactly what I'm trying to do is how do I abacify everything that's happening in public school? Mm-hmm. In the mainstream, how do we abacify? So that's the other, you've heard of Singapore math, right?
Yes.
Singapore math is actually Eurocentric math. They just decided to go to Singapore. The problem is it's still Eurocentric. So the questions are not curated. So the questions are not curated like Abacus is. What does
curated mean?
Curated means the questions are very specific, like adding 3. This is all the ways you can add the 3. There's only 2 ways to add the 3, plus the 10, plus the 10, plus the 5. That's the only 2 ways. But so when I showed you in here, right? These are all the different scenarios to add the 4, but it's the same way, right?
Yes.
plus the 6, or minus the 6 plus the 10, minus the 6 plus the 10 gets to the point. So the questions are very specific, just like my multiplication, right? 2 times table, 5 times table, 3 times table, all of it is just the same thing over and over again. Whereas in mainstream, the questions are curated, but they're curated by patterns, like know your doubles plus 1, know your doubles minus 1. Whereas in Abacus, and the way I did it is I curated to the specific number.
Mm-hmm.
They're very so that's why my books are, you're hopefully you're not going to see that you mix the 5 and you mix the 10. If you don't know it, they're not together yet, but they will be together later. So it's curated. There's stages of my books. There's stages of Abacus. And that's what I did with, you saw the, oh yeah, I didn't do multiplication yet, but that's what I did with multiplication.
Mm-hmm. Mm-hmm. Yep.
Right. And it's the same thing with my adding books. All my adding books is everything is, you don't need a formula. This is what you do. You need to plus the 5. These are all the things you do, right? I'm isolating the questions for this only until you become comfortable to master and then see it in other forms, like double digits, triple digits, quadruple, 4 digits or whatever. Because once you add in those digits, it doesn't matter. Abacus will still follow suit. But because we know the foundation, it doesn't matter if it's 2 digits or 3 digits. You saw that. You saw that in the in these questions.
Yep.
Right? It doesn't matter.
Mm-hmm.
But because we know it, and it goes back to mastery.
Yeah. This has been good.
That's when you ask questions. When you get the bigger numbers, that's when you ask questions.
Okay.
I wouldn't do it when it's in the beginning.
Because they're learning. Okay.
Yeah.
Yeah, because then it becomes like you're checking off something. But just because you check off something doesn't mean you've fully understood it.
Yeah, exactly. Exactly. You just go through the motions, but not really understanding.
You're going through the motions, not really understanding.
Mm-hmm.
And yeah,
Mm-hmm.
that makes sense.
So
I've enjoyed this. I have to run because I have to go pick up my bountiful basket, but
yay, good.
I'm going to be going back to this because I'm going to take notes of what we talked about.
Okay. These are great. These are the reason why I like I have the office hours.
Yeah. So
thank you so much.
I'm going to be getting your multiplication book and getting some of your books. So thank you so much. I'm really glad I was able to ask those questions, and I'm going to do those multiplication ones.
Okay. I'm actually working on a 2-digit times 2-digit multiplication book pretty soon, as well as division.
Do you have the division almost there?
No. No, because I still want to get the kids' books for multiplication out the door. But
okay.
Yeah, that's the problem, like priority. My priority actually right now is to get book 3 done. And book 3 will have the chaining equations. That's why I wanted to get the vocabulary. Mm-hmm. So it's going to be advanced. It's going to be advanced as well. So. Okay. And so that's the other thing I was thinking about is I was going to add in more pages of activity, but the answers, you just got to sign up for the answers to be online and it'll be free.
Oh, so you won't have answers in the book.
That's what I'm thinking.
That's a good idea.
That's what I'm thinking. Because one, the kids always look at the answers and I'm like, and then my mom cheats too. So like, okay, maybe if we can add an extra barrier, I'm going to, put in more questions, still fill it up to like 109 pages, but it would be it'd be one page. Here's a QR code for the answers. And there you go.
I like it.
That's what I was thinking. Yeah? Okay. Mm-hmm. Okay. So far, it's okay. So far, it's been a consensus. because yeah, you're not going to pay extra for it. It's just going to be somewhere else.
Yep.
You know what I mean? Because
Yep.
there's no point of paying for answers.
That's true.
So, but
That's true.
but then it'll be easy for me to do it that way, because then I don't have to worry about, because then I just have to give you like a link, a Canva link, and you can just go page by page, and it will match.
Okay.
Yeah.
Yeah, that'll work. Wow.
Yeah. That would be one less
an
step.
advanced grade. I mean, I know you call it grade 2, but
yeah,
it's just it's just a grade, but it's something that I think it's awesome. Abram, yeah. So he's at a good spot. I will continue to do the +5 -10 book, but seriously, I think this second grade book is a combination of all of that.
Yes, it is. It is.
And so I might just jump to that.
That's fine too. That's why I give it to you.
Yeah.
I gave you that option so you can, because don't forget, he's also a little bit older than what I had planned for these ones. These ones were meant for kids that are coming from preschool, kindergarten.
Mm-hmm.
So,
yeah.
And
that's why I'm jumping him into, because he has been able to do those, those problems on the Abacus anyway. He knows exactly what he's doing. And so this just gives him a little bit of a challenge, and we just start slow.
Yeah.
So.
Yep. You're perfectly fine if wherever that's where, and that was the goal. The goal is to find where it fits in, especially since I'm still building out all of the stuff. If this works for him, then do that. You don't need to go through the +10s, because all the information is the same in the second grade one.
Yeah. Right now, the reason why I wanted the second, because he gets into coloring, making it look pretty.
Yeah.
And I'm like, let's just answer the questions on the side. Then let's go back and do the coloring. Can we do that, please? So, because there are some days we'll be like, why are we spending an hour?
Yeah.
And then the other day he did 3 pages of it wasn't the Abacus, but he did 3 pages of the Math with Confidence in 8 minutes.
Good.
So, and I know so, and then so he could do good. So I don't know. Yeah.
It's just as I said before, he can do more than 5 questions.
Yes,
it just depends on what it is.
Yeah, it does. And if I don't bother him too much, that's the part I need to back off. I've seen him do, it was one of your sheets in the
that's right. It was like a maze book. It was a maze sheet. He was able to do it.
It was 2 digits, or I forgot what it was, and he did that in like I don't know, 8 minutes too. So it is possible.
It is possible.
So well, great. I'm looking forward to next week. So
yes, thank you again.
Yeah.